Hello and welcome everybody to Accudata Systems webinar on hyperconverged infrastructure. My name is Joseph Huff and I'm a data center solution architect here at Accudata Systems. We have created this webinar because we've really listened to your feedback, and we provided this hyperconverged infrastructure session today because we feel that it's something that is pertinent to the IT landscape. We thank you for listening to our webinar today, and without further ado, we'll get started. So my name is Joseph Huff, and I'm a data center solution architect here at Accudata Systems. I've been involved in IT for better than 20 years, and I've had many experiences throughout the data center in my lifespan as an IT person. I've been anywhere from a small IT guy to all the way to big oil and gas to working for government entities. So I've leveraged a lot of that experience over the years. With that said, let's touch really quick on who Accudata is for those that are not familiar. We've been around for about 30 plus years, and we've grown from a small accounting data center integrated firm to covering all areas from an IT perspective. We've really leveraged our experience with our customers and their feedback to really gain insight into how we can better help them in their industries. So with that, let's talk about what I've seen over these past 20 years when it comes to IT. The really interesting thing that I've noticed in my years is we all seem to have the same problems, and that is back in the day we had a simple issue. We had an application we wanted to deploy in an environment, so we bought a server, we put an operating system on that server, saw the application, and then we just continued on. It was pretty much that simple. Well, as things have become more and more complex, it's not that simple anymore. Now we have things like storage area networks, we have all these security tools, we have storage area networks, we have virtualization. All these things are making things so complex, and with that, the costs have gone up as well. So all this complexity and cost has made it really hard from an IT perspective because our headcounts are not trending in that same fashion. So we're trying to do more and more with less, which is making it a challenge to be flexible for the business. So at the end of the day, we're seeing things go up and up and up from a cost and complexity standpoint. Our headcounts are staying the same, and then we are losing some of the flexibility that the business requires in an IT environment. And then there's the whole term of cloud. Where does cloud fit in? From a security standpoint, from a economic standpoint, and then how easy is it really move to the cloud? There's some contributing factors that are to these problems. Okay, first of all, we have really smart users these days. And back in the day, whenever I was a help desk person, I could get away with a lot of things. You know, our users weren't very savvy, I'll say to speak. So nowadays, they're really smart, and a lot of that has to do with smartphones. So people are looking for things on demand. When they want an application, they want it up and running very quickly. So part of these smarter users is coming from a generation that I have. I have 3 kids, 2 in college, so I can identify with this generation very well. They are termed the millennials. These millennials have no concept of patience. They want their applications now. They use text messaging, and they get responses really quick from all their friends, right? Well, these are the users that we're going to have to be supporting here now and in the future. And just some scary stats to throw out there for you is 75% of the workforce will be these millennials in 10 years. 77% of these millennials want to be able to use their own mobile device. Of that, 88% want to work on their own terms. They don't want to work 8 to 5. They want very flexible hours. So if you think about that, that's where things like Citrix and being very scalable is very important to your business, and really important to your users, which falls back to complexity, cost, and being flexible to the business. The last stat is 50% of the workforce will be contractor or some type of consultant that is coming into your environment. So all these things are what's causing to this complexity. The next part of that is we're seeing this change with these smarter users. The businesses are seeing technology as an enabler and not just a cost center. I know from my experience working in oil and gas for 10 years, we didn't provide any special services that made money for the company. All we were was a cost center in which the business had to pay for, right? Well, now that is changing. We can see that technology is enabling the business to be faster, more agile, and providing new services to be more profitable, right? But with that, again, comes complexity and cost to the environment. The other part of the cost issue is that storage is a major component of this increased cost. One of the things that I've noticed is that nobody has a storage or data deletion initiative within their environments, right? We don't delete anything. We are all hoarders of our own data. We always want to make sure it's there. We don't want to delete anything because we just might need it. So with that said, we have to continue to add more and more storage to our environments, which increases our cost. So one of the things, the last thing is around the cloud. So having that highly available, flexible infrastructure that allows us to get on-demand stuff. So what is the impact of all this? Well, our users become less efficient. If we can't provide applications in a timely fashion, then they're going to struggle with coming to us for more and more resources. We tend to spend more. We're trying to be reactive to the situation. So instead of maybe investigating newer technologies, we're just going to buy what we've used in the past because, well, it just works. So we're just going to keep spending more money and maybe lose some innovation. Business outcomes get impacted. So a process may take up to 24 hours or 48 hours just because, well, that's just how long it's going to take, when we could probably find better ways to do that if we had more time and to be more innovative. Business revenues can get impacted. So I'll use the example of when I bought a house. So about in 2002, my wife and I bought our first house. We used this thing called the internet, and we used a website called HAR, so Houston Associated Realtors. Okay, and we did some research. You could put in the parameters that you were looking for, where you wanted to live, how many bedrooms, all that kind of good stuff, and it would show you a list of houses. So we found the house we wanted. We contacted the realtor. He let us look at it, and ultimately we ended up buying it. I'm not sure what the realtor did. I think my wife should have got paid the 3%, but we won't go there. But let's fast forward to 2014 when I sold my house. We told the realtor, they put it online, but now there wasn't just one website. Now there's apps on your phone that you can do a search right from where you're at. Let's say HAR never took advantage of that capabilities. Would they still be in business today? Would people use their site to find that house? I'd say no. They would go to Zillow or Realtor.com or Dweller, all these other ones when the application can be right at their hands. So HAR did follow that trend and leverage technology to help better their business and make sure they're following that trend of users. So it really helped them stay relevant. The next big thing that I've seen is acquisitions. So we are in an age right now where acquisitions are becoming more and more prevalent as the market is going up and down in certain areas. And the last thing we want to do is make acquisition costs become an IT problem. We don't want to go to our vice presidents or C-level type execs and say, well, we can't integrate these systems, so we're going to put this acquisition on hold. That could look really bad on IT, right? The next thing is this term called shadow IT. So I mentioned earlier where our users want these resources on demand and want them really fast. Well, if IT is a hindrance to that, they're going to go outside of us and that's where this term shadow IT came from. We have customers going outside of IT, and there's a stat out there that says at least 29% of IT spend is outside the IT organization. That means your users are going to these cloud-like resources like Amazon, like Azure, these software as a service applications, and spending money because we can't provide those services quick enough or fast enough. So this term shadow IT is happening. Now we at Accudata have done these what we call SaaS audits, and we have discovered that this is a lot more prevalent than you would anticipate. So that's something we can talk about offline or reach out to your account manager, and we can provide that audit for you if you want. Now with all that said, that's all the bad stuff. The good stuff is that our manufacturers that we partner with have found ways to help us improve this experience to our users. I'll use flash storage or solid state storage as an example. So our manufacturers have found ways to leverage flash. Again, we can thank Apple and the smartphone for making flash relevant to all of us. And Intel has made it where these drives have gotten much bigger, and we can produce much faster performance for our applications. For example, being in the storage industry for as long as I have, the fastest spinning drive was around 15K, right? So 15K RPM was the fastest we could ever get a hard drive to spin that platter, which made it around 180 to 200 IOPS per drive. So my experience in oil and gas was we didn't just have a rack of storage, we had rows of racks of storage to be able to provide the capacities and the performance that was desired by those applications. Well, now with flash storage, where a particular flash drive can produce anywhere from 2,500 to 3,500 IOPS per drive, we can really start shrinking that footprint down, provide capacity and performance at a much smaller scale. So it's been a really interesting turn in how storage is provisioned, how storage is sized, and how we can really get a lot of benefits from those devices. The next thing is hypervisor and virtualization. Again, I told you back in the day we would build a server, put an application on it, and that was the end of the day. Well, over time, and as you scale out, that becomes harder and harder to manage. It becomes harder and harder to keep power and cooling under control. So when VMware came out, it was a kind of an aha moment where people said, hey, I can take this and not just run some small applications or test dev. I can use this in a production scale, and it became a more enterprise-grade solution. So we've seen a lot of people, I would say in the high 90 percentile of our customers, are leveraging some type of virtualization environment to provide some of that flexibility that we weren't getting, that our customers were asking, but also from a footprint perspective in the data center, it's really grown out. And with all that, we're seeing this term where things are becoming more and more software-only type solutions. So this Gartner quote where they predict by 2019, 70% of existing storage array products will also be available as software-only versions. So I'll use an example there. EMC is one of our large partnerships, and they have provided software versions of their data domain, of Isilon and VNX as well. So being able to leverage storage and then provide those software services on top of that storage to the end users is going to be very, very attractive. The last thing I'll talk about on this is cloud and software-defined data center, or private cloud. Now, my definition of cloud and then software-defined data center, private cloud, is this. Some of you may have virtualization in your environment, and I'll say you probably have a virtualized data center with VMware or Hyper-V. Private cloud means we're providing an Amazon or Azure-like experience on top of that platform. So that includes a self-service portal, some type of automation orchestration built into that. So when I say private cloud, that's what I mean by that. And that is what's really changing the dynamics of how we build these infrastructures going forward, is we want to provide that on-demand look and feel just as if they would a public cloud where they can go in, choose their resources, hit go, and through some approval process, they get something spun up, whether it's on-prem or off-prem. So really changing the landscape of how IT is built going forward. So with that said, we've kind of tackled this in two different ways. So over, at the beginning, I'm going to call it the DIY. So kind of build it yourself. So we've taken some servers, we've taken some networking devices and some storage, and we've built this virtual data center the way we thought it needed to be built. Now I can tell you from experience in IT for a long time, and again from my home buying experience, that works, but sometimes may not be the best option, right? And I'll use when I first bought my first home, I wanted to build this deck because it had a pool in the backyard. I was like, it'd be cool to build a deck out here. So, I went to Home Depot and I bought, I went to Home Depot several times, put it that way, and I bought all the wood and everything I thought I was going to need to build this deck. So it took me a long time to build it, and then after looking at it, it did kind of lean one direction, but I was able to fix it. But every time it rained, it would lean another direction. So I was constantly having to maintain that, and got to the point where I knew when it rained, I would just go out there and fix this little widget, and it would bounce itself out. That's pretty common in a DIY infrastructure as well. So a lot of times we know how to build it, and when something happens over time, we just figure out how to fix it, and it takes us a few minutes. Now, like my house, when I sold it, the next poor guy that bought it was going to have to figure out how to fix it, and if he didn't know how to fix it, he may just tear down the deck and build a whole new one. And some of you may be in that transition period when it comes to your IT infrastructure. You've come in and you're like, what was this guy thinking? I need to redo all this. Or you're the guy that built it and you know exactly how to fix it. So some of you are probably in one of those two phases, and you kind of probably identify with where I'm going with that. That's how we used to do it in the beginning. And then again, our manufacturers came up with ways to let's see how we can bundle this stuff together. So things like reference architecture and convergence came into play. So when I say that, I'm talking about FlexPod, SmartStack, vSpecs, and vBlock. Those terms, if you've been in IT for the last 3 or 4 years, you should identify with. And it's kind of like buying a car, right? I need a car that's going to fit 2 people and needs to go this fast, and it's all under one maintenance agreement, right? Makes it easy to buy, easy to purchase, and easy to maintain. So if I have a problem with that car, I take it back to who I bought it from, and they can fix it pretty easy because they know everything about that car, how it's put together. The problem with that, on top of that, is that, well, what if that car is not big enough? And I'll use this example. So, you're a single guy, you buy this car that fits 2 people, and it goes 100 miles an hour, and that's great. Well, then you meet somebody and you get married, and you're still 2 people, so you can fit in it, and everything's going to be fine. However, there's this debate on, you want 2 kids and she wants 4 kids. So the question is, where do we go from here? Do we buy the SUV that's going to support the 2 kids? Or do we have to go out and buy the dreaded minivan because we're going to have 4 kids? Well, we just don't know. So we probably end up buying the minivan just because we may end up with more kids than can support the SUV, right? Well, that's how hyperconverged is. And I'm going to pick on EMC a little bit just because I can. So we have this idea of storage, right? We buy a vBlock, let's just say 340, okay? And that comes with a VNX 5400. Well, that vBlock 5400 and that vBlock 340 can support X number of blades and X number of storage on the VNX 5400. When I grow out of that, I've got to trade it in or upgrade to another platform that can hold the amount of data that I need. And that's the dreaded forklift upgrade, right? That's what we want to kind of get away from in the next kind of platform. So that's one of the good things, bad things when it comes to hyperconverged. It's well maintained, it's simple to purchase, everything works together, it's all integrated. However, we typically over-purchase because we don't know what our futuristic needs might be in a 3 to 5 year platform. So to kind of highlight this, you kind of have your DIY, and these are probably all familiar products, HP, Dell, Cisco, when we've built our virtual data centers in the past. We've seen our converged infrastructures and reference architectures with BCE and vBlock, NetApp and FlexPod, and then Nimble SmartStack. Now, I'm going to say today, in the next 5 years, this is where hyperconverged is really going to be the game changer in the market. I see this as being a huge enabler to our businesses to be able to be super flexible, compatible, cost-efficient, and easy to maintain going forward. And we'll get into the details of the different products here that are in this window. The first thing I want to do is really kind of get to the nuts and bolts of hyperconverged. And I would try to make it as simple as possible. Some of you may have an idea what hyperconverged is. Some of you may have your own version of what hyperconverged is. And some of you may have no idea. So I'm going to hit the least common denominator and kind of start from a simplistic view of what hyperconverged really is. Okay? So to kind of think about this perspective, if you've ever seen on TV or whatever, you've probably seen these supersonic trains in Europe and in Asia and places like that. They go like 200 miles an hour. Well, think of that train as each one has a motor, each one has power, each one has capacity for passengers. Okay? So in this particular picture here, we have two cars. And let's just say that each car holds 25 people to keep things simple. So this particular train right now could hold 50 people. And ticket sales are around 45, so we know that today this 2-car system will work just fine. Well, what happens is the next day they sell 65 tickets. So what they have to do is they're going to add another train car. Now this has capacity for 75 people. They all have power, motors, and capacity. So now this train can have 75 people and still go 200 miles an hour. In a nutshell, that's hyperconverged. I have compute resources, I have storage resources, and networking resources all on each one of these nodes. They share a common infrastructure, and they share resources across all these. So in this example, each one of these nodes can support 25 different virtual machines. That's it. That's hyperconverged. So to kind of double click into this, I can kind of break it down this way. In this example, we have 4 nodes in this cluster. Each one can support virtual machines. All the storage is leveraged together. So let's double click into this, what I'll say is a VMware cluster, right? We've got a VMDK file that each one has a certain amount of blocks. Those blocks are then distributed across every single node within that cluster. Some of you may look like this and go, your storage guys, and say, this kind of looks like RAID 0. And I'd say, yes, it is very similar to RAID 0 in that we are striping the data across all the nodes within the cluster. The next thing is data protection. So depending on the vendors, which we'll get into here in a minute, and the level of data protection you want, we create replica copies of each one of the blocks across each of the nodes. By doing that, we're getting data protection in the event of a failure. So what happens in the event of a failure? This particular node goes offline for whatever reason. This would be very similarly to your traditional environment where you have ESX hosts and traditional storage, right? That node goes down. Those virtual machines are then distributed across the surviving nodes. They're leveraging the storage on the back end to get those nodes back up and running. We can use those replica copies to get those virtual machines back online. Now, let's say this was a simple event and that node gets restored within a matter of less than an hour or something. That node would get brought back online. The blocks would be redistributed, and the VMs could then be moved back to that particular host. Pretty much that simple. Now, in the event, let's just say we are starting out with a 3-node cluster. Okay? How do we scale? So we have 25 virtual machines on each one of these hosts, and we are pretty much getting maximum capacity out of compute, memory, and storage currently on this particular cluster. If you wanted to scale, all we would do, again, is just add a new node to the cluster. The pool of resources get expanded. The data is synced across all the nodes, and virtual machines can then be distributed across all the nodes within the cluster. That's pretty much it. So that's hyperconverged at a very high level, right? Now, some of you might be thinking, this is pretty cool. I could see this being the next thing, best thing since sliced bread. And I'll say, it could be the silver bullet, but not exactly. So I'm going to get into some use cases here in just a second of when hyperconverged has done really well for our customers. But just to kind of highlight and put some context around it, it's not the silver bullet, right? There are certain workloads that may not benefit from hyperconverged environment. And those would be your really large storage environments where the compute is low. So again, we're using node-based architecture here. So there's only so much storage we could probably put on a node. And then with data protection, it gets even smaller, right? So something in the hundreds of terabytes, and you only need maybe 3 or 4 nodes in a cluster may not be a good sense. Video streaming would be another example from an application side. Video streaming data doesn't really dedupe all that well or compress very well, and a lot of these platforms leverage dedupe and compression to help get the usable storage footprint up on a node base. So for those, may not be a good use case. That's where somebody like us, like Accudata, can come in and really help work through those requirements and see if hyperconverged is or is not a good fit. So with that said, let's talk about some of our use cases. So our first one is from a mid-sized energy company. They were looking to have about a 500 user VDI deployment. We went through a VDI pilot program and to see which one would work. And we tested Citrix and VMware to see which one would kind of win out. And Citrix was the leader in that particular pilot, so it was very successful. So from there, we went to a POC where we expanded the user base, and the customer was all in and said, this is the right way we want to go. They had a lot of people that wanted to take advantage of using their own devices and being remote and those kind of things. So Citrix was a nice, easy product to bring in and meet all those different requirements. However, the challenge was they were mid-sized, right? So they had a lot of good infrastructure, but with things like SAP and SharePoint and a lot of these higher-end applications, with 500 users, that can put a lot of strain on some existing infrastructure. So how do we find something that would be able to fit into their environment, and they could start with, say, about 200 users. So as their devices were rolling off of maintenance, so their laptops and desktops, they were going to start pushing these people to VDI. So they want to buy all 500 user footprint up front. So with that said, working with the customer, Hyperconverged really made a lot of sense from a cost perspective, because what they could do was they could buy enough resources for those 200 users up front, and they could simply scale out one node at a time, just like I've talked about before. So from a cost perspective, it made a lot of sense from a CapEx. On top of that, with it being hyperconverged, the footprint was really small. So from an OpEx perspective, they didn't need a lot of cabinet space to do this, and it made it easy for them to consume those resources as they were adding more and more and more, right? The next thing is leveraging Citrix on the back end for the VDI sessions and load balancing and all those kind of critical things. It just became a nice, complete, total package that made it easy to consume, easy to manage, and easy to deploy from that perspective. And it was a huge win for the customer and a huge win for Accudata. The next use case is remote site. So we've seen a tremendous increase in use cases. So I can tell you when Hyperconverged first came out, it was really focused around VDI. Just because of the way it scaled, the way it was consumed, it was really efficient in that perspective. But now what we're seeing now with this increase in IoT, so the Internet of Things and the IoE, Internet of Everything, this large oil and gas customer was looking for something to put at those remote sites where they could take advantage of these technologies. Now they were, I'll be honest, they are a huge vBlock shop at their main data center. They have like 3 or 4 of these massive 700 series vBlocks, but it wasn't something that was easily deployed at these remote sites. A lot of times there was either zero IT out there or very limited IT at these places. So the challenge was, how do we find something that would be easy to deploy and easy to manage remotely and kind of centralize all that kind of stuff, plus making it something cost effective, right? They had kind of this idea of a small, medium, large. They were looking at small being just a common infrastructure with simple services like Active Directory, file serving, and some applications. The refinery sites and rigs where they would be consuming a lot of data, so getting all that telemetry data from all these devices that are participating in the IoT, that needed to be a bit of a medium to large environment depending on the number of devices that they were collecting data from. So we needed something that kind of fit that formula for those guys. So the Hyperconverged solution gave them a very flexible option that they could tailor to those specific environments. So they could go with, say, a small 3-node cluster for those small branch offices. They could ramp that up to some higher-end blades or higher-end nodes that would be, say, maybe a 4 to 6-node cluster, depending on how much data, and then to the larger ones, they could even scale past that. So they kind of be able to cookie cutter the Hyperconverged solution to meet those different objectives for those different sites. On top of that, it gave them the ability to easy deploy it. And I'll get into a demo at the end of this where with one of our providers that can show just how easy it is to deploy. And then what they could do was bring it in-house, develop it, build it, ship it out to the site. And all they needed was a quote-unquote smart user that we have in the field to plug up the power networking, and it was online, ready to go, and they could start deploying the applications, and it was ready for those end users. So it was really win-win for them, and really provide that software-defined data center for their entire environment, not just in the main data center. So a huge win for them and huge wins for us as well. The last use case I want to talk about is the data center refresh. And this is something that I personally am involved in. This is something I have meetings about with my customers on a week-to-week, day-to-day basis, right? We have aging infrastructure. I need to refresh it with something new. This particular use case was a nonprofit in the Dallas area. So a nonprofit meaning that I'll just be honest, once they buy something, they keep it for quite a while, 5, 6, 7 years. And a lot of times what they'll do is they'll buy whatever's cheapest at the time. So this particular customer had some HP gear, they had some Dell gear, and they were trying to figure out, well, how do we consolidate these things? Because they've kind of created some silos based on the cost of the stuff going forward. So how do we solve their pain today, but then not introduce pain in the future, right? We want to solve their pain today and provide a solution that would be sustained for the next 5 to 7 years. On top of that, it's got to be something that's really cost effective, right? Being as a nonprofit, they don't have a lot of money, so we need to make sure that it's going to fit. On top of that, they're trying to move to a colo, right? So the challenge is, how do we find something that's cost effective, reducing their OpEx, and then minimizing their CapEx at the end of the day? So the challenge, Hyperconverged was a perfect fit for them. They were able to consolidate everything to a single solution that was compute, memory, and storage all in a single platform. It really minimized the footprint because of the node-based architecture, which I'll get here to in a minute. We'll talk about that for this particular customer, why it was a lot of savings. But they could get everything into one rack, right? So from an OpEx perspective and a colo perspective, it really helped them from an OpEx. From a CapEx, they bought a single unit again, right? So it's compute, memory, and storage all in one box. So consolidated that. And then it gave them the ability to grow as needed, right? So as they wanted to bring in more applications down the road, they could simply add one node at a time, and it was easy for budgeting. So they could add that one node at a time in the pay-as-you-grow. From a life cycle perspective, this solution could carry them in well into 5 to 7 years or beyond, because as new requirements came in, they could add newer nodes to the architecture, and then they could decommission, and they wouldn't have to do any data migration going forward. So that was a really value add for them as an entire solution. So solving the pain now and then providing that solution really long term without disrupting any of the services down the road. Okay? So who does Accudata support? We have 4 primary hyperconverged solutions that I'll talk about today. Cisco HyperFlex, Nutanix, VCE/EMC VxRail, and Simplification. So I'm not going to get into every single one of these. I'm going to double click into these in just a minute, but just at a high level, some similarities. Pretty much VMware's table stakes across the board for all these. A couple of them offer some other hypervisors like Hyper-V. We'll get into that in a minute. Data protection standard across the board. They all offer snapshots, protection, some replication things inside there. Inline deduping compression. They all offer that as well in some form or fashion. We'll get into those in a little bit. Encryption is a key thing here for our medical customers. HyperFlex and VxRail do not offer that today. Nutanix and Simplification do with the self-encrypting drives. That is roadmap for both of those vendors. It's just certifying that those SEDs will work with their solution. So we should expect that sometime into this year, 2016, or first part of next year, 2017. With that, 1 gig, 10 gig across platforms. And as far as scalability goes in hardware platforms, they pretty much all start with a minimum of 3 to 4 node configurations and can scale at a single node architecture. So to kind of double click into this, we'll talk about Cisco HyperFlex first. This is one that is really I think a game changer from the way that it's kind of architected. The Cisco UCS platform has been around for quite some time now, and this is leveraging that platform. So it's leveraging the fabric interconnects on the back end. So this is the only solution that has 10 gig networking built into the actual solution. The other ones all require 10 gig infrastructure that you have to provide outside of the hyperconverged solution. So with the ability to leverage the 10 gig and the fabric interconnects, we can start with the 220 nodes, which is the 1Us, the 240 nodes, which is the 2U, which holds 24 drives, and then we can also come up with a hybrid. So if you go back to the picture before where we have the scale out of the nodes, we can also, with the HyperFlex, add compute-only nodes to the mix. So they'll have this ability to connect to that storage via the virtual controller virtual machines that are built into the solution. So if you need more compute and not any storage, you can add a chassis and have that compute added to the environment. This is really key for a VDI type solution where you would have your VDI sessions or your workload servers that would be attached to the storage, which would be these 240s or these 220 servers. But yet we have infrastructure nodes like the brokers and some other things that the storage requirement may not be that big, but we still need compute resources. So they could sit outside of those workload servers, but leveraging the storage within that solution. So pretty cool from that perspective. The next one is, we'll talk about is Nutanix. So Nutanix was kind of the innovator in this space when it comes to hyperconverged from a commercial perspective. The person that kind of built Nutanix from the ground up was originally at Google, where this kind of idea came from. And they've had probably the longest run rate from a availability perspective. So they have quite a lot more models, so 1,000, 3,000, 9,000, all the way to 8,000. And really the differentiators is, you know, the number of nodes per chassis, and obviously the processor memory and storage capabilities of the different nodes. One of the things that they have done differently is they have developed their own hypervisor. So they have built their hypervisor called Acropolis, which is kind of based on the KVM system. I kind of use this as an example. You know, they've done Acropolis kind of like what Red Hat did for Linux, right? So I'd say that's kind of where that comes from. So they do both inline and post-process DDoP compression. The inline DDoP compression is only on the all-flash versions. The hybrid versions today are kind of post-process, so something to keep in mind whenever you're coming up with data storage footprints. The other thing is that they don't just run on their own Nutanix hardware. They're also certified to run on Dell, and Lenovo, and UCS. So the 1000 series, just to highlight, will work on a 1 gig network. All other platforms require 10 gig. So again, you can have whatever 10 gig platform you need on the back end. It's just something that is kind of a requirement because of the data services built on the back end. Okay. Simplicity. So the differentiator for them is, again, they have three different models here, or I guess 4 different models here. The differentiator for them is they use a PCIe card. So you've heard me talk a lot about data services, so deduplication, compression, snapshot backups, those type of things. This PCIe card they have offloads all that from the hypervisor. So kind of a knock on Nutanix and some of the others is they need CPU and resources to run their controller VM for the storage side, and sometimes that can take up to 48 gigs of RAM, where Simplicity does not have that requirement. Everything's offloaded on this card, which has CPU and memory built into it to provide those data reduction services. They have capability to do WAN optimization and replication on that card, which can really help from a data protection standpoint. So this platform, I'd say, while it doesn't, it may be lacking in some features, where they hang a lot of their importance is on data protection. So something to look at when on their platform. And again, they're certified on UCS, Dell, Lenovo, in a hybrid format, all flash or hybrid. Last one I'll talk about is the Dell EMC VCE platform called VxRail. So it is similar to Nutanix. So I took the back shot of these because on the front end it's just a nice pretty bezel like all the others. But this is how Nutanix and the VxRail look on the back end. It's a single chassis which shares power and cooling, but that's it. Everything else is got its own individual networking, its own outlets for monitoring and management, all that kind of stuff is all done externally, which is why we require 10 gig on the back end. So their differentiator is they leverage VMware's vSAN as their software-defined storage. So all the other ones have their own version of that. Dell EMC has gone with VMware's vSAN to provide that software-defined storage. So until I hear otherwise, it's only going to run on VMware because it's using VMware vSAN to build that software-defined storage. And again, they do inline DDoP compression and all that kind of good stuff based on the vSAN platform. So with that said, I did want to show you guys a demo to kind of give you an idea of what that's going to look like. And I'll kind of talk through that as the video is going. And you can really see how easy it is to deploy a a hyperconverged solution. So with that, I'll jump into it. You'll see. So this will be for the Cisco HyperFlex solution. We actually have one of these in our demo lab, and we've deployed it with great success, and we've been able to bring it up and tear it down as much as we want fairly quickly. But here's the interface. So you have the option to create a new cluster or expand, and obviously we're going to create a new cluster. We're going to import its configuration file, which is a JSON file, and what that's going to include is kind of your basic information, right? IP addresses, subnet masks, gateways, names, and some basic information, right? We're going to put in some passwords that we'll include, and then we're going to go out and discover on the Fabric interconnects all the different nodes that could be potentially HyperFlex nodes. So once we do that, we're going to pick those and then basically start configuring them. And the way this works is for Hyperconverged, and this is kind of across the board on some of the other ones, is there's a deployment VM we put out there within vCenter, and it's running this for us, and basically input all this. It's going out and talking to those, and then we're inputting all this information. So from there, we're just going to basically apply all the information that we would need, whether this is HyperFlex. We've also done Nutanix and VxRail as well. So this is similar to all those other manufacturers out there. This was just nice and easy since we already had this built in and it's fairly new. So again, once we identify all of the information within this kind of quick start, we're just going to hit start, and it's going to go out there and talk to the Fabric interconnects. And it's going to build all the service profiles that we need. Once it builds all the service profiles, it'll then deploy the hypervisor, which for us was going to be VMware. It's going to install VMware on those particular blades once the service profile is deployed, and then it's going to build that cluster and put it into vCenter. Once it's in vCenter, it's going to build the storage pools, the networking, and everything that we've inputted into this system. So you can see why somebody like a large oil and gas customer that doesn't want to spend a lot of time building the stuff on site, they can do all this either locally on-prem, rebox and ship it out, or they can have somebody deployed in the field, basically just turn it on and get it on the network, and then we could deploy this remotely. So this is why it's a big win for us in a remote branch office or kind of refinery type environment where IT may not be available, because we can do all this through vCenter. So again, we've got deployed validation. It's now deploying all the nodes within that cluster. And just so you're aware, this is not time increase. This is actually how long it's taking to deploy this. It's literally going to take about 5 minutes or so to get this up and running. Once we deploy all the nodes, the next thing will be to validate all this. So we're going to validate everything's up and running on each of the nodes. We're then creating the cluster, which will take here just a few minutes. And then once we're created, we'll jump into the web console of vCenter so you can see how everything is plugged up together. Just a few more seconds here. All right. Almost done. Everything's healthy. And here we are. This is the web console from vCenter where we have a cluster deployed here. And this is just a web plugin. No need to go direct to the Hyperconverged system. This is all done through vCenter. So from here we can see the amount of storage we have, and we can really kind of dig into some of the details as far as what's involved in this particular cluster. So from there we'll actually click on the details here, and we're going to get all really kind of cool information, right? So we'll be able to see storage, how much we're used, how much provisioned, what kind of savings are we getting from a dedupe and compression standpoint. And next we'll see the status of all of our nodes. We can see here this is a 4-node cluster. Each one is online. We can also capture some performance, which we'll dig in here in just a little bit when we go to the next section. So we go to monitor, and from here we can really see exactly how the cluster is performing. No third-party tools. This is all built into vCenter. So we can actually get custom views. We can actually trim this down to a specific time frame from an IOPS, throughput, and latency perspective. So we can see the last 3 hours. How did it look from each one of those metrics? And this is pretty valuable information. A lot of times we don't get this right away from our current platforms. We can check the events of the cluster, what's happening from that perspective. And then the rest of the events will be inside of the vCenter, main vCenter alerts and events window. This is just pertinent just to the cluster itself. So from a managed perspective, this is our nodes right here. These are our disks, what disks are currently in the platform. And that's just saying if you wanted to find out which drive you could just turn the blinking light on. These are our data stores. So if we need to see our data stores, if we need to edit them, if we need to create them, we can do that right from here. So if we need to edit a specific data store and make it larger, everything's thin provisioned, we can just come in here and say, make that 2 terabytes. It's updated. It's going to update all the hosts within vCenter. You want to create a new node, a new data store, give it a name. How big do you want to use it? It's all thin provisioned, so we can create a 20 terabyte data store. It's there, and then it automatically will update all the hosts within the cluster, making that storage available. That's pretty much the simplistic view of Hyperconverged in a nutshell. It's very easy to use, it's easy to deploy, and simple to manage. So from there, what are the next steps? You've seen the product, you know who we support. If you've liked what you've seen today and you're like, I wish I had my boss here, or I wish my internal IT guys could see this and then get their take and they can ask questions. I would say reach out to your Accudata account manager, and we can take this deck on the road with me, so I can come out and present this to your staffs, and we can do a little bit deeper dive in each one of the products if you'd like, or deeper dive into Hyperconverged as a whole, and kind of dig a little deeper if we need to. We can also, some of the things we can do is we can help prepare you. So some of you, again, were like, wow, this is pretty cool. I wish I could see how this work in my environment. So we offer is some complimentary storage and VMware health checks to kind of see if you're a candidate for Hyperconverged, if you're looking down that road. If you have renewals coming up and you're like, do I renew my existing stuff, or should I take this opportunity to maybe refresh? We can come out and do those kind of analysis. And the next thing that I'm excited about is we've worked really hard on a data center cloud evolution workshop. And what that is that the top 10 or 15 hot topics that we've seen for 2016. We've talked about Hyperconverged today, but we have data around all flash arrays, data center security, cloud, hybrid cloud, all these different things that we see are hot topics with our customers. We can bring that to you, and it could be we could do it over lunch, we could do it over a couple hours in the afternoon with your staff. But it just kind of gives you an idea of what's going on out there and what the hot topics are. So if there's any questions, I know this is a webinar that you're probably watching, but I would say there's a landing page that you can get to on the Accudata website that could, if you have questions, please reach out to your account managers, and we can schedule some time, whether we can come on site and discuss those with you, or if we need to do it over WebEx. We're going to be as flexible as we can to help you out in this space, and we're really thankful that you were able to come in and take some time to watch our Hyperconverged webinar. And with that, thank you very much, and have a good day.